Alright, in this video I'm going to introduce a result called Parsevals identity, which is related to Fourier, the Fourier series, the Fourier theorem. Alright, so the Fourier states that if a function is piecewise continuous and 2L periodic, then it can be expressed in terms of sums of sines and cosines in a form given by 1, where the Euler coefficients are given by 2, 3, and 4. Now, if that holds, then Parsevals identity states that the integral of the square of f over minus L to L, well, times 1 over L, is equal to the square of a naught over 2 plus the summation of the squares of a n and b n. Okay, so we're going to do a derivation of this to show you how it works out. So if we start with 1, what we're going to do is we're going to multiply 1 by f. So we're going to multiply 1. Going to multiply 1 by f of x. So if we do that on the left hand side, we're going to have f of x squared. On the right hand side, we're going to have a naught over 2 times f of x. Then inside the summation, which we can multiply into because we're multiplying by a term that does not involve n, have n pi x over L here. Then we are going to have bn f of x sine n pi x over L. Okay, this is summing from 1 to infinity. Then we are going to integrate. So we are actually going to multiply by 1 over L and integrate from minus L to L. Okay, so every term I multiply by 1 over L. So this term, so I want to integrate whatever with respect to x. So on the left hand side, we're going to have 1 over L, the integral of f of x squared dx. This first term here, we are just going to have a naught over 2 1 over L integral from minus L to L of f of x dx. So that's this term here. Then next is this term here. So we are going to have summation of an 1 over L integral from minus L to L f of x cosine n pi x over L dx. So that was this term here. Then last is going to be bn 1 over L integral from minus L to L f of x sine n pi x over L dx. And sums from 1 to infinity. However, from 2, 3, and 4, okay, Using 2, 3, and 4, we know that this is just A0. This is AN. This is BN. So the right hand side, we already have what we are looking for. So this thing now becomes 1 over L integral from minus L to L of the square of F. Then gonna have A naught over 2 here. Okay. Then here there's going to be AN squared, and the identity has been derived. BN. All right. So that's Parsevals identity. In the next video, we're going to do an example, 1 or 2 examples, and then that's going to be. We only at 6 minutes. Maybe we'll do an example even in this video. Right. So let's look at some examples. In the video on half range series, we showed that this function here, defined over this interval, has got a half range cosine expansion, which is given here. So in number A, use the series to show that the sum of these reciprocal powers of 2n minus 1 squared equals to pi squared over 8. All right. So this is the function we're going to use. So just remember that so this is x over the interval 0 to 2. Okay, so from 0 to 2 is equal to x. So what we are going to do, we are going to use the value, any values between 0 and 2 that are going to simplify these nicely. Okay, so first we want to note that, so this n equals to 1 to infinity. When n equals to 1, this is 1 squared. When n equals to 2, this is 3 squared. This is 5 squared. So this is basically just the sum of odd reciprocal odd squares. And if you look at this series we're given, we do have these here. So you can find the value of x in this interval, which is going to give the numerator to be 1 or even -1, then that should give us some progress. And well, this is between x equals to 0 and 2. We choose x equals to 0, it's going to be cosine 0, cosine 0, cosine 0. This side, that's going to be 0. So we can go for that. So let's see how that works out. So set x to be equal to 0. The left hand side is going to be 0. Right hand side is going to be 1 minus pi squared over 8. Then we're going to have 1 over 1 squared plus 1 over 3 squared, etc. 1 over 1 squared, 1 over 3 squared, 1 over 5 squared. Then all you need to do is to make this the subject of the formula. We bring both sides. If you bring this term to the right hand side, this is pi think we have got a small error here. It's 8 squared over pi, not pi squared over 8. Not a squared, it's 8 over pi squared. So 8 over pi squared. So 8 over pi squared, 1 over 1 squared, 1 over 3 squared, 1 over 5 squared is equals to 1. So if we take the 8 over pi squared to the right hand side, then we have the result we are looking for. 1 over 5 squared is going to be pi squared over 8. Okay, so that one is done. Number 2, use Parsevals' identity to find the value of this infinite sum. So for this thing we have got f of x b. F of x is x. Bn is 0 because it's a half range cosine expansion. A0 is 2 actually, because that's why we have 1 here. It's 2 over 2. Then an is negative 8 over n squared pi squared, but this is for odd values of n. An is negative 8 over pi squared to n minus 1 squared. So we're simply going to slot this into the statement of Parsevals' identity. So remember, our interval is 0 to 2. So this is going to be 1 over L minus L to L f of x dx is equal to a naught squared over 2. Bn is 0, so it's just going to be an squared there. However, f of x squared is going to be even whatever f of x is. So that means we can do a symmetric thing here. 0 to L, put 2 there. Okay. So it's going to be 2 over 2, 0 to 2. F of x is just x squared dx. A naught is 2. So we're going to have 2 squared over 2 here. Then we are going to have minus 8 over pi squared to n minus 1 squared to infinity. If we do the integration here and everything, we get, okay, so integrating this left hand side and plugging in the limits is going to give us 8 over 3. So 8 over 3 here. It's 4 over 2, which is 2. Square of 8 is 64. Square of pi squared is pi to the power 4. So it's going to be 1 over 2n minus 1 to the power 4. So I want to make this the subject of the formula. So if we bring 64 over pi to the power 4 to this side, 2n minus 1 squared, it's going to be 8 over 3 minus 2. 2 is 6 over 3, so it's going to be 2/3. So that means the summation of these reciprocal odd powers, this power 4, is going to be pi to the power 4 over 64 times 2/3. This gives us 32. So 32 times 3 is going to be 96. So this is 1 over 1 to the power 4, 1 over 3 to the power 4, plus 1 over 5 to the power 4. But we want 1 over 1 to the power 4 plus 1 over 2 to the power 4, 1 over 3 to the power 4, 1 over 4 to the power 4. So let's call this S. Now if we call this S, can we use this to find the value of S? And indeed we will try. So this is the first thing we do. I'm going to split S into 2. So I'm going to have the odd powers, or the powers of the odd integers, 5, okay, separate. I'm going to have the even integers, 1 over 4 to the power 4, 6 to the power 4, etc. Well, this one we have is this one here. So we can plug in pi to the power 4 over 96 there. Then this one is a common factor of 1 over 2 to the power 4. So it's 1 over 16. If you factor that out, then this is 1 over 1 to the power 4, 2 to the power 4, 3 to the power 4, etc. But this is just S. So we're going to have S equals pi to the power 4 over 96 plus S over 16. Then if we make S the subject of this formula, we find that it is equal to pi to the power 4 over 90. Okay, and that is that.